Welcome to The Explainer. Today, we're going to break down the technology that decides what lands in your spam folder and, helps your phone recognize your face.
So how does your email know what's spam? And how does your phone pull off that face recognition trick? Well, the answer to both is actually the same thing. It's this really powerful process that lets machines learn from examples. We call it supervised learning, and trust me, it is working all around us all the time. So let's get into it. How does this whole thing work? Well, the best way to think about it is like a machine learning with a teacher. Seriously, it has a guide, you could call it a supervisor, that helps it figure out the right answers. Okay, so the absolute key here is that the AI isn't just, guessing randomly. No, hey, it's trained on a huge, massive data set where all the correct answers are already labeled. It's kind of like studying for a test, but you have the complete answer key right there with you. That lets it learn the pattern so it can eventually tackle problems it has never, ever seen before.
Now, this is totally different from other methods, like what we call unsupervised learning. In that case, the AI gets no answer key. It just has to figure out the patterns all on its own. And you can imagine that is way, way harder. That's exactly why supervised learning, with its nice, clean, labeled data, is the most common and frankly powerful approach in AI today.
And once you know what to look for, you start seeing this whole learning with a teacher thing everywhere. It's literally what filters your spam. It's what suggests who to tag in your photos on social media. It even helps banks decide who gets a loan. It is constantly working behind the scenes of our digital lives. Okay, so to really get our heads around how a machine can actually learn from examples, we've got to go back, like way back, to the very beginning, to the first time anyone tried to build a single artificial brain cell. So back in the 1950s, you had all these scientists who were totally inspired by the human brain. But they knew they couldn't just build the whole thing at once, right? So instead, this one psychologist, a guy named Frank Rosenblatt, he focused on a much smaller but brilliant goal. What if we could just create one artificial neuron that worked like a real one?
And get this, he actually built it. The machine was called the Perceptron, and it was massive, like the size of a grand piano, all hooked up to a camera. Its entire job, this whole giant machine, was to learn just one simple thing: how to tell the difference between a triangle and, well, not a triangle. And that simple learning process, it laid the foundation for pretty much all supervised AI today.
So the way it learned was so simple, but just brilliant. The Perceptron would look at an image and make a guess. If it got it right, the human supervisor did nothing. But if it was wrong, the supervisor would give it some negative feedback, and the machine would physically adjust its own internal wiring. Think about that. It literally learned only from its mistakes.
All right, so today's AI doesn't have a bunch of physical wires, obviously. The whole process is digital now. But the core idea, how a single neuron makes a decision, it's surprisingly similar to that old machine.
So a modern digital neuron works like this. It takes in different pieces of info. We call them inputs. Then each of those inputs gets a weight, which is just a number that says how important it is. All those weighted inputs get added up, and if the total number crosses a certain line, a threshold we call a bias, the neuron fires. It makes a decision. So let's see how this all works with a classic AI challenge: telling a donut from a bagel.
Okay, so just imagine for a second that we plot every donut and every bagel on a graph. Maybe we use their weight on one axis and their diameter on the other. The AI's entire job is just to learn where to draw one single line that best separates the donuts from the bagels. That line, that's what we call the decision boundary. Anything on one side is a donut and anything on the other is a bagel. Simple as that.
So once our AI has been trained, how do we know if it's actually any good, right? Well, we have to test it. We give it a bunch of new data it's never seen before. And because no AI is perfect, the real goal isn't just about counting the successes. It's about really understanding its failures.
This table you're looking at is called a confusion matrix, which is a great name because it shows us exactly where our AI got confused. So let's look at that top row. We can see there were 25 actual donuts in our test batch. Our AI correctly spotted 8 of them, but it got 17 of them wrong, calling them bagels instead. Wow, that is a lot of missed donuts.
Now, if we just calculate the overall accuracy, add up all the correct guesses and divide by the total, we get 81%. And hey, 81% sounds pretty good, right? But that one single number, it hides a much, much more important story about where the model is actually working and where it's really falling down.
To really get the full picture, we need to look at two other numbers. The first one is called precision. And precision basically asks this question: when the AI says, hey, that's a donut, how often is it actually right? It's all about the quality of its positive guesses. Because you really don't want to bite into what you think is a donut and get a bagel, right?
Okay, so the second number we need is recall. And this one asks a totally different question. Of all the real donuts that were in that batch, how many did the AI manage to find? So see, recall is all about quantity. It's about asking, did we miss anything important?
So, let's look at our donut finder. The precision was 80%. Not bad, right? That means when it said something was a donut, it was usually right. But the recall was only 32%. I mean, think about that. It missed over 2/3 of the actual donuts in the batch. So it was precise, but it definitely wasn't very thorough.
And this really highlights this constant trade-off in AI between precision and recall. Which one is more important? Well, it depends entirely on your goal. Think about a spam filter. For that, you absolutely need high recall, right? You would much rather have a few spam emails slip into your inbox, that's lower precision, than have one super important email from your boss go missing. That would be a catastrophic failure of recall.
And all of this brings us to what is, without a doubt, the biggest challenge in supervised learning. And AI is only as good as the data its teacher gives it. So what happens when that data is biased? Well, if the data contains our own human biases, the AI won't just learn them, it will amplify them. And figuring out how to understand and correct for that, well, that's the real key to building fairer and ultimately more effective AI.